All right, we're making progress. As I was just saying, it's been a while since we've met. We got to figure out where we're at. I think we're week 7 in the schedule. Let's take a look at that real quick. Sounds right. Let's go to okay. Weekly assignments. 5, that's actually, yeah, week 5, week 6. Yeah, I think we did that. That was where we started with functions. So I'm thinking it's week 7 we're at, which I think starts us on structures. Maybe this is just more functions. Yeah, these are just more functions. 7. Well, let's take a look at what the book's all about here. Functional M files was chapter 6. No, we did chapter 7 too, which was output options for functions and inputs. So we did chapter 7 as well, which I believe is week 7. So we're at should be down here. Week 6. Week 7. Use the input function and a user-defined function prompts the user to input a value for x and returns. Yeah. So week 7 is the last homework assignment because it has the user-controlled input and output. And that's where we learned things like the input function and the fprint function, the display function. Yeah, so we used that one. So we should be in our chapter 8 and week 8. So if you haven't done week 7's homework, get that done. Shouldn't be terribly challenging. And then we're starting on the stuff for week 8 today. How many weeks do we have left? It looks like we have 8, 9, 10, 11, and 12. So that's 5 weeks of assignments to do. In the semester we have, it's April, so I think we have 6 or 7 weeks left. Let's take a look here. We have 1, 2, 3, 4, no, we have 5 weeks left till finals week. So we may not have time to squeeze in our final project. We may have to just finish what we've learned here and do a short thing at the end. In big part due to all those things we missed in the past few weeks for my sickness and spring break and also the inter-high days. Those really kill us. But anyway, that's where we're at. Chapter 8. Let's go ahead and get started. Logic functions and selection structures is what we're in right now. Logical functions and selection structures. And what does logic mean? Logic means yes, no, right or wrong, one or two, one or zero rather, on or off. Essentially it means it's a function that chooses between one of two things. And that's what logic is. It doesn't necessarily have to just be one of two things, but when you get down to the nitty gritty, it ends up being that. And so like a true and a false kind of thing. And then selection structures, when we talk about selection, we talk about choosing something when a certain condition arises. So we're doing something, we're doing something, we're doing something, and we choose to stop doing that when a certain condition arises. Or we're not doing something, we're not doing something, and then a certain condition arises and we try to decide to do something. And those are, of course, important in programming because you want programs that can react to certain conditions and make things happen when they need to happen. So that's what we're going to be doing here. And these are often called loops, although they're not always, they don't always relate to that word, but they're often called loops. So let's start off with just our very basic logic stuff, which we call operators, the operators of logic, or the operators of selection logic. So it goes like this. Let's start off with some definitions of some variables. First of all, we'll have x equals 5, we'll have y equals 6. Now we've got a couple of variables stored away in our workspace. Now, we can ask MATLAB a logical statement, ask it a logical question, and it will give us an answer. One of those logical questions we can ask is x less than y? And it will give us an answer. Turns out the answer is 1. Because MATLAB is a computer program and a fairly lower level computer program, it's not considered extremely high level because it still requires you to learn how to code, how to use the code. Something that's considered high level is like Windows or Microsoft Word or something like that, where you pretty much need to know how to see things and you need to know how to read a language like English. But this language requires us to know something about computers and computer programming. And so it gives us an answer instead of a yes or no, in a Boolean answer in ones or zeros. And in ones and zero Boolean language, Boolean meaning logical or kind of same thing, two answers. 1 is yes, or positive or affirmative. 0 is no or negative or, not. You can also ask the question, a similar question, instead of is x less than y, you can ask is x less than or equal to y? And it also says no. Or you can ask, is x greater than y? Sorry, the answer is yes, right? 1 was yes. This one is no. Is x greater than y? Which makes sense since x is 5. So is x greater than y? And the answer is no. And then you can also ask, is x greater than equal to y? And ask that question, the answer is no. So those are 4 of the operators. X less than, greater than, less than or equal to, greater than or equal to. Now the equal to always goes after the greater than or less than sign. But you can also ask if x is actually equal to y. And the way you do that is not x equals y, because that already has a, that already does something in MATLAB. You have to say x equals y. So that asks the question, is x equal to y? And then you hit enter, and of course it is no. Or you can ask if x is not equal to y. You put the little not symbol, which is the sigillia, which is up in the left-hand corner above your tab key usually. So you say x not equal to y. And it will say yes, it's not equal to y. So those are all of the operators that we have. And these operators work on numbers, but they also work on, they will also work on an array of numbers or a matrix of numbers. For example, if we make x equal to 1 through 5, like this, right? And let's let y equal -2 through, in steps of 2 to 6, like this. Oops. Not underscore 2, -2. There we go. Then we've got 2 arrays of 5 numbers each, and we can ask, is x less than y? Is x less than y? Right? And it'll give us an answer for each term, term by term, is x greater than y. So it takes the first term of x and the first term of y, compares them. Turns out that x is not less than y for the first 2 terms. And it's the true for all of them until we get to the very last term, where x is 5 and y is 6 and x is finally less than y, and it gives us a 1. Right? So that is a representation of how this can be done. You can also compare x with a single number. So if I have z equal to 2, for example, here, z equals 2, and I say, is x less than z? Then it will answer that term by term again. It will take the single number z, which is 2, and it will say, is x less than z? Yes, it is for the first one. No, it isn't. For the second one, no, it isn't. For the third one, no, it isn't. For the fourth one, and the fifth one, no, it isn't. So on. So anyway, that is, those are called the relational operators, and those are used in all kinds of logic and also situational loops, or whatever we call those, repetition loops, selection structures as they're called. But then we also have logical operators, and the difference between the relational operators and logical operators is this. Relational operators are going to ask you to compare 2 things, and asking a question, asking some specific question. Logical operators actually are going to be, what's a good way to describe logical operators? Logical operators are kind of like connection operators, but they connect things in specific ways. For example, the AND operator is a logical operator, and when you use an AND operator, you're telling the computer to include something with something else. So x and y, you include them together and you combine them together to kind of make 1. Then you have the OR operator, which is an exclusive operator. It excludes, well, it's not exclusive really, it's kind of a separation inclusion operator, where you're talking about x or y. So it's either something in one or something in another, or part of one or part of another, but not necessarily part of both. So you have AND operators, you have OR operators, you have NOT operators. You also have NAND operators, which is not an AND. You have NOR operators, which is not an OR operator. It's kind of the opposite. So I mean, they're kind of weird to get used to at first, but once you see them in use, you'll start to understand them. Using them is really the key. So let's talk about, let's do this here really quick. We've got already x and y. Let's put in a new z. X is 1 through 5, y is -2 through 6 by 2s, and z is now going to be all 8s, it looks like. A row of 8s. That sounds good. So we've got these three things in our workspace here, x, y, and z, and we're going to use some operators, some of these logical operators to ask some questions from the computer. So one of the things that we can ask, we've already asked before, for example, is z greater than x? We've asked a question like this before, and it's going to compare term by term by term, and 8 is always greater than the numbers 1 through 5, so the answer is always yes. However, we can also ask the question, is z greater than x, and is z greater than y? Right, so we can go z greater than y. So that asks two separate questions. And what it's asking here is there a situation where z is greater than x and z is greater than y? Well, let's ask the question. And it turns out, yes, every single situation. Every z is always greater than x, and it's also always greater than y, because we have ones in every spot, right? However, if we ask this question slightly differently, is z greater than x and is z less than y? What do we get? No. Z is always greater than x, but it's not always greater than y. It's never less than y. So both of those statements aren't true. The AND operator here is returned as 0 because both of those statements aren't true. And that's why it's called an inclusive operator, because you have to include both of these comparisons in order for this whole thing to be true. Z has to be greater than x and z has to be less than y for this to show a 1 in any of these places. And it's not true in any of those spots, so it's never true. And it might have been true in one spot or another if we chose something specific. For example, let's choose the question that we should ask now is z less than x and is z less than y? Let's see if that's ever true. No, that's not true either. What is z? Z is 8. Oh. Let's change x really quick. I'm going to open up x here. I'm going to change the fifth term of x. Instead of being 5, I'm going to make it 10. And I'm going to go ahead and close that out. So now I've changed x, and I'm going to ask one of these previous questions, which is I want to ask the question, is z greater than x and is z greater than y? Okay. Now before, when we did this, we got 1s across the board. Z is always greater than x and z was always greater than y. But in this case, I'm going to get one term out here that's going to return a 0 because in x I have a 10 in that fifth spot, which is greater than z, which is 8. Right? And so it's true for all these other ones except that last term, the comparison of those last two terms. It's not true. So that's the AND. Both of these statements have to be true to get a 1 in each spot. Okay? If both of these statements are true in the first spot for the first comparison, then it's true in the first spot. You get a 1. If they're not both true, you get a 0. If they're both wrong, you get a 0. If anything goes wrong, you get a 0. The next one is the OR statement. And actually, let's do the same one that we did before. This one here is z greater than x and z less than y, or sorry, and z greater than y. And let's actually put in another operator here. Let's put in the not. Let's put in this guy. Not and. So this should tell us when these are not both true. Oops, I didn't do it right. I'm jumping ahead of the book really quick because I wanted to demonstrate that one, but I'm obviously not using it exactly correct. We'll save that for another day. Okay, so let's move on to the OR operator. Where were we? Here we go. So the OR operator, you can do a similar thing to this. Instead of having an AND, just replace it with the OR, which is this straight up and down thing. There we go, like that. So this is asking the question, is z, is z greater than x or is z greater than y? So if either one of these is true, then you're good to go. It's a 1. If one of them is false, it doesn't matter because the other one was true. If either one is true, right? So hit enter. And it turns out that's always correct. If either one of these is true, you're good to go. And it's true in every case. This last one ends up being 1 because in one case, the z is not greater than y, but in the other one it is. The z is not greater than the y, but it is greater than the x, and so it counts. And, you get a 1. So that is, well, we have one more here. The one more that we're going to use is, let's see, do they ever use the not? I don't think they do. No. The next one is the shortcut and. The shortcut and is just 2 and statements. And the shortcut or is just 2 or statements in a row like this. And those mean the same thing, but what they do is they shortcut the computation time. Because what the shortcut and does is it checks term by term to see if both things that you've asked are true until it comes to a point where they're not true, and then it just stops doing computation because it knows that it's not going to be true. And the same thing with the or. It just keeps doing it until it finds a mistake. And if it finds a mistake, it stops. And what that can do for is if you're making very large computations, it can cut down computational time. But in short computational stuff, it doesn't really make any difference. You're not likely to use it. But MATLAB actually has a lot of stuff like this. And this is the first time we've really encountered it. MATLAB is often used to crunch humongous amounts of data. Just crazy, crazy amounts of data. And if you're going through and you're doing some kind of an and statement, an or statement with, just gazillions of data points, you don't really want to go through and keep calculating if you don't need to still calculate. If it's already false and you aren't going to keep calculating if it's false, you want the computer to know to stop and to start the next calculation. So that's kind of where that comes in. All right, now is the time. We've learned how to write functions. We know how to write functional files and everything else. Now is the time to really start to learn how to write real code, how to write a real program. We have most of the tools in our tool belt. We're going to learn a couple more here, but we do want to learn how to do code. And this is built into the homework assignment, I believe. Let me check the homework assignment. Let's see the homework assignment. Okay, so we're supposed to be in week 8 homework assignment. If we go into week 8 homework assignment, right here, question 2, it says this: please read and complete the flowcharting worksheet and submit this worksheet. So you open up this worksheet. It's a Microsoft Word document, so you should be able to open on just about any computer. And, whoa, that's not what I want. This is what you should see. This is a worksheet to learn how to flowchart. How many of you have done flowchart before? Okay, a flowchart is a way of outlining an idea and using logical statements to organize that idea and to follow it from inception to completion. And when it comes to programming, what that means is you want to be able to outline your program and show where data comes in, where the user has to make an input, where things get calculated, where things get split into different, put into different places, where you bring them back together to do something, where there's inputs, outputs, calculations. You want to show where those things are going to happen without actually writing the code. And this is the idea of flowcharting. Pseudocode is another thing that we we talk about, and this is part of it. But pseudocode is just like an outline of what you're doing on paper and with paper and pencil, where you just kind of write down the idea of what you want to do without having to write down all the code of what you want to do. And maybe you write down some of the code because you remember some of it, but maybe you just make notes. But this is the idea. Let's actually take some time. I think there's a good video about pseudocode. Let's go find the video about pseudocode really quick. Pseudocode. What is pseudocode? I like this picture best, so I'm going to go with this one.
Welcome to Workspaces, an exclusive tool created by Treehouse. This is where you can start coding.
Welcome to 5 Minutes to Code, Programming Basics with your host, Matthew Seattle. In this series, we are going to look at the fundamentals of computer programming. So whether you are hoping to program in Python, code in C# or to develop in Java, these short guides should help you get to grips with the basics to get started. You won't need to download or install any software, so just sit back and enjoy. In this series, we are going to be looking at sequence, selection, and iteration, as well as pseudocode and flowcharts. Today, we're going to look at pseudocode. So let's look at this in more detail.
Okay, here is an example program written in pseudocode. It both does and doesn't look like a computer program. The syntax is similar to most high-level computer languages, but at the same time doesn't have the exact syntax. Pseudocode is often referred to as a syntactical representation of a program. Why do people use pseudocode? Well, it has two very useful uses. Firstly, it can be used to help non-programmers understand what is happening in a program. The second use for pseudocode is for when programmers are trying to debug and solve a logic error in a computer program. As it is closer to spoken language, it often helps programmers find where the program is going wrong. Let's look at our first program in pseudocode. Okay, the first line is pretty straightforward. It is a comment. A comment is ignored by the program, and it is used for us humans to read. It helps.
So in MATLAB, instead of a hashtag, what would we use? We'd have a percent sign for that, right?
Helps us remember what something does, and if you are part of a team of programmers, it can help explain what it does to another programmer. The second line, the A variable is assigned the value of 10. This arrow means assignment. It is similar to a single equal symbol. In this case, A equals 10. The same thing is happening with B on the next line. However, B is being assigned 20. Line 4 totals A plus B together and assigns it to C. So C is now equal to 30. On line 5, D is being assigned C divided by 2. This effectively halves 30 to 15. So D is now being assigned 15. And finally, print D. This is an output command. It takes something from the computer program and shares it with the real world. It outputs the value of D to the screen, which in this case is 15. So there you go. You can have comments, variables, and outputs in pseudocode. But that is just the beginning. In fact, most things can be achieved in pseudocode. Let's look at another short program. This simple program takes 4 user inputs and adds it to the total at the end. The first line is a for loop, 0 to 4. The variable count is initially set to 0, and every time around the loop it adds 1 to it until it gets to 4, and then it breaks out of the loop. The first thing it does in the loop is to ask the user to type in an exam score. The next line, number equals user input, assigns the number that is input to the variable score. Following this, it adds it to the total variable by taking the existing total and adding the new score to it. It then calls next count which effectively adds 1 to the value of count and goes around the loop again. Once it has done this 4 times, it creates the average by taking the total and dividing it by 4, and assigning it to the variable average. Finally, it prints the words the class average and the average as an output. So there you go. We have now added for loops and inputs to the mix. This is just a short guide to pseudocode. Now that you have the basics, don't hesitate to dig deeper into it and flowcharts as well.
So hopefully you can see that pseudocode is just a little bit of shorthand for code that you can write down. And you can do it any way you want. His method is fine. There are other methods. Many people who write code have their own little method. It's like their own little shorthand for writing down what they want to do. It gives them enough information, enough detail that they remember what they wanted to do there, but not so much detail that they're actually writing down every line of code and doing all this syntax that we're used to doing, making sure it's filled out right with the right number of parentheses and all this junk. You just say, well, this is what I want to do. I know how to do it. It'll take me a little more time to do it and a little more effort, but I'm just going to write down what I want it to do here. But it does have to have a fair amount of detail so that you don't forget how you're going to do some things. You just don't want to say, do this program. You want to be able to kind of step it out step by step how that program works and so that you know how you're going to write it in the end. Now let's take a look at flowcharts.
Thanks for watching 5 minutes to code. Code. My computer art programming tutorial.
Okay, let's see if he's... I don't want computer art.
They take online learning to the next level and make it easy and fun. Treehouse has amazing courses.
I want pseudocode. Or not pseudocode, I want
And you'll love their high quality videos, interactive quizzes, and
flowcharting. Well, anyway,
start creating.
flowcharting we actually do have a thing for. So a flowchart is another example of how to organize this information. And they talk about it here in your book, and then this flowcharting worksheet also talks about it in more detail. Talks about the different symbols that are used in flowcharts, the start of a program, computational steps. So these are things that you're actually calculating, right? Input or output operations, anything that's coming in or out of the program. Decision making, so these are your logical operators. Is it less than or this, greater than this? And then it can go off into different directions from here, branching off into different directions. Connecting parts of a program, you circle them. You can have a magnetic tape, which we don't use anymore, a magnetic disk, which we do. So this means that you're storing something, so you have something that goes to one of these cylinders, that means it's storing it. We don't use this anymore. Then the flow lines are just arrows in various directions that can go up, down, sideways, whatever. And then display or print is that one. And then they show you some examples of how these things can be used. So from a process symbol, you should only have one flow line in and one flow line out, either side to side or down, up and down. But for the decision symbols, you can have multiple out for a single in. You should have one thing come in, then this thing makes a decision and it can go out to multiple places. And then for terminal symbols, you should have one flow line either in or out, because that's the end or the beginning of the program. These are comments right here. These dotted lines that come out, those are comment lines. And then, but the advantage of this is it actually gives you a visual representation of where things are going. So here they start off with a very simple program. You start with just the start of your program, and you have this variable sum is going to equal 0, then you have this variable n that's going to equal 0, and then you take n and you add 1 to it here, and then the sum is going to equal sum plus n, and then you have this logical operator, is n equal to 50. If it is equal to 50, you print it. If it's not, you go back around and you come back here and you add 1 more to n. So you added 1 to n when it was 0 to make it 1, now you add 1 more to n, which is 1 now, and it makes 2. And then you add sum to sum plus n, and you get 2 plus 3, 2 plus 1 rather, and you get is n equal 50, this gets 1 and 1 plus 1 rather, it becomes 2, is n equal 50, no. You go back around and it keeps doing this, and it's just counting, it's counting up to 50. It's just a very simple program, not meant to do anything really important. Once it gets to 50, it prints 50 and it's done, okay? But this shows you kind of the flow of information, the flow of data, the flow of ideas and decisions. So that's the reason it's so valuable. Now, in the second example, they're going to talk more about these decisions, right? You come down here, you're going to read these values, these data values. This is a data input here. And then you're going to make a decision. Is A greater than B? If it is, then you're going to go to the right. If it isn't, you're going to go down and to the left. So you're going to have 2 paths to go, 2 things to do if it isn't. If it isn't, then you ask another question, and then you also print C. If it is, then you ask another question, and you go from there. So these things can have many branches going many different directions, even at the same time. But they still show you kind of what the computer is doing in a very visual way. It's kind of nice. And as you go through this, there are some questions to answer, some things to get out of the reading in this that you need to fill out and turn into me. But then at the very end, there's an example that they want you to do. They give you a situation, they give you a program that they want you to do, and they give you a flow chart to fill out. And you're supposed to fill in the blanks into this flow chart with the different calculations, the different variables that you're going to assign, and create a program using a flow chart. They actually do 2 of these, now that I'm looking at it. So there are 2, and then at the end there are some questions as well. So this is the first part of your homework, is to learn some more about flow charting, and that's all we're going to talk about in class. I'll let you guys learn that on your own. It's mostly learned on your own. I've given you the basics. You should be able to apply that now on your own. Now, going on to the next section. We've got still a couple more sections to do here. Can't remember how long we spend on chapter 8. Let's go check that in the homework too. We might spend 2 weeks on chapter 8, which would be a problem. Yeah, so we're actually not going to get all the way through chapter 8 if we follow the schedule, because chapter 8 is split into 2 homework assignments. It's split into week 8 and week 9. It splits it goes to selection and loop structures for week 9, I believe. Let me check this really quick. Well, we do selection structures this week and loop structures next week. So we might just try to cover all of chapter 8 today. We've probably got time to do it. And that's fine. Okay, so let's look at some more ways to use logical functions, and then we'll go to selection structures using those logical functions, and also using some flow charting examples, and then we'll move on to the switch and case structures, which are more selection structures. My goodness. Wait a second. No, chapter 8 is all selection structures. It's not till chapter 9 that they do loop structures. So we're good. They changed the book and I forgot. So we don't have to worry about week 9's assignment this week. Week 9 will be next week. Let's just worry about selection structures using these logical operators we've got so far. So let's go back to MATLAB and let's do some more examples here. We've got to enter in some more things here. Let's actually clear out our everything here and close everything. So we're starting nice and fresh here, and let's make we're on page 276 in case you're wondering. Let's make an array of numbers of people's height in inches. So we'll have somebody that's going to be 67 inches maybe, and somebody who's 82 inches, they're nice and tall. Somebody else who's 76 inches, that wouldn't be a bad height either. Somebody who is 68 inches, someone who is 55 inches, they're short, and somebody who is 75 inches, and that's great. So we've got all these numbers now stored into our workspace. Let's imagine that we are only going to want short people to operate our equipment because the place where the operator has to sit can only accommodate somebody who is less than 6 feet tall. 6 feet tall is 72 inches, of course. I think, yep, 72 inches, right? And so we're going to select somebody. The only people that we'll accept for this job are going to be the people who are in this group of people that we called height. So we're going to use this function, the find function, and the find function will accept a Boolean statement, or not a Boolean statement, but a selection statement. So we're going to select from height everything that is less than or equal to 72. What we're asking it here is we're asking it to tell us what numbers in the group of numbers that we call height, which of those numbers is less than or equal to 72. We hit return, and it tells us. It tells us the first one is less than 72, the fourth one is less than 72, and the fifth one. So the first one, 67, the fourth one, 68, the fifth one's 55. All the rest are greater than 72. So it returns essentially the index or the placement of the number in that array of numbers. And then you can use that as you need to. We could also do decline. We're going to decline all the rest of these people. So we can use decline equals find everybody in height that is greater than or equal to, right? 72. No, just greater than, not equal to. Greater than 72, and so we're not going to consider the people that are in slots 2, 3, and 6. Now, of course, for a small group like this, no big deal. But if you have a huge group of numbers, and you're only looking for certain numbers that fit a certain criteria, this is extremely useful. You can separate out the ones that you want very quickly and very easily. In the book here, they create a table of the people who are tall enough or aren't tall enough or too tall or whatever. We've done that before, so I'm not going to go through it. We need to move on a little bit here. So here's another example of using this and using some syntax that we haven't used in a little while. So we'll do this example so that we can remember how to do this. We'll need to use this soon. So we're going to make a new list of people, applicants with heights. I'm just going to put in random numbers. I'm not going to try to make them real heights. But we're going to do this. We're not going to just do heights this time. We're actually going to do heights and ages. So I'm going to do this differently. So we're going to have a height of a person, for example, 63. But then we're also going to put in their age. in the same row. And then we're going to make a new row. And the new row will have another height and another age. And then another row. Oops. We'll have a new height and a new age. This one was supposed to be 19. Doesn't really matter, but we'll try to do it the way they do in the book here. 72 and 20. 69 and 36. 78 and 34. 75 and 12. So this is, of course, a group of numbers that has 2 columns and however many rows that is. I don't know, it's like 7 rows. And now we want to start selecting things, but maybe we'll only want to select things from certain rows or from certain columns, right? So maybe the first thing that we want to ask is, are you old enough? The age being the second column, we just want to choose from the second column. So let's say age is going to be equal to, then we're going to find something, but we want to skip the first column and just look in the second column. So we're going to look in our thing called applicants, but we're going to skip the first column. And if you don't remember how to do that, what you do is you put parentheses after the applicants, and inside those parentheses you put a semicolon, or a colon rather, and that tells us to skip the first column. And then we put in a comma, and we tell it which let's see, is that right? Oh, yeah, they're doing something else. So what they're going to do first is the first thing that they're going to do. So actually, this colon here, this colon doesn't mean to skip the first column. It means it's telling you which column to do. So that says we're going to look at columns, comma, first column. So we're going to look at the first column and we're going to ask if they are a certain height. We want them to be, according to this thing, they want them to be greater than or equal to 66 inches. So greater than or equal to 5'6". So we put greater than or equal to 66. So that's the first question that they're going to ask. But then we want to ask another question. We want them to be greater than 66 inches, but we also want them to be older than 18. We want them to be 18 years or older. So we use the AND operator. So we want them to be 66 inches tall, and we want applicants to be, and we're going to choose a column, and the column we're going to choose now is the second column, because we're going to do the age, and we want that second column to be greater than or equal to 18. Okay? So next, the next one, we're going to use an AND, because we also want our applicants to be not too old, which is actually against the law, but that's what they're doing anyway. So we're going to choose the second column again, but we want this one now to be less than 35. So those are the requirements that we're looking for. There are 3 of them. We've connected them with 2 AND statements because we want all three of these things to be true. And it's going to just go term by term by term and check to see what's happening here. So we hit return, and it finds that the second applicant, the fourth applicant, and the 6th applicant all meet these criteria. Well, let's take a look, see if that's true. The second applicant is 67 inches tall and 19. The first one doesn't meet it because he's 18 but not tall enough. The fourth one, 72 inches tall and 20. The 6th one, 78 inches tall and 34. Of course, the 12-year-old who's 75 inches tall is not only extremely tall for a 12-year-old, but only 12 years old, right? So can't do the jump. Anyway, that's how we can use all those things together to do things, to find things here. Let's see. Here's another thing that you may have forgotten how to do, which is to build a table. You can build a nice table like this by saying that the results are going to be equal to this array of numbers, where inside the array of numbers we're actually going to put numbers from our thing that we called applicants, right? So we're going to put it from, we're going to take, first of all, we're going to take the numbers that we have from pass, and then in the second column here, the second space in the first row, we're going to put in the thing from applicants, and the thing that we're going to put in from applicants is going to come from pass 1, pass comma 1. So, and then the second one, or the third thing in here is going to be applicants pass comma 2. Now, what does this mean? What this means is that we're taking these numbers right here. The numbers from pass. This one was called age, so I'm actually going to use age, not pass. I called this age. I don't always follow what they do in the book. I kind of look at it to begin with, and then I don't always use it in the end. But anyway, we're using age, and so what it's going to do is it's going to take this column and put this in the first column, in the first thing here, so that we have the number of the applicant, right? The number of the applicant is applicant number 2, for example. And then we're going to have the second thing is going to be the age of, the height of the applicants, because we're going to take number 2 and for the row, and then number 1 for the column. So number 2 is going to be the row, 67, and column 1. So it's going to give us 67 there, which would be the applicant's height. For this one, it's going to be age, comma 2. Age is going to be 2, so that's going to be the second column in applicants, and it's going to be the second row down as well. So it'll be 19, which is the age. And it'll do it for each one of them. It'll do it for 2, for row 2, for row 4, and for row 6. But this is something we're just going to store. We're going to store this in the thing we call results, and then we're going to use that to make a nice little thing. We could actually print this to the page as well. It wouldn't be a bad thing to print. If we print it, this is what we get. Applicant 2, applicant 4, applicant 6, applicant 2's height, applicant 4's height, applicant 5, 6's height, and their ages and so on. But now we want to put these numbers into some kind of a statement that actually tells them this. And so we can do that. We can do that using our display command. Here's our display command. It's disp, right? And it goes like this. You have to use a quote to start your typing. You say, the following candidates meet the height requirement Right, the following candidates meet the height requirement, and then I can close that out, close my parentheses there, and I can actually maybe put a semicolon in there or something like that. Following candidates meet the height requirement, and then I can do an fprintf. Now remember that display just puts this on the screen, right? But if I do an fprintf right after that in my M file or whatever, if I do an fprintf, then I can take things out of my arrays and print them to the screen. For example, I can say in fprintf, I can say candidate, and then I can use this syntax, number percent that tells me what kind of thing I'm going to be writing. 0f is %4 tells me what kind of thing I'm writing again. 0F tells me I'm writing here. And inches tall. Now I have to tell it, I'm going to do a new line here at the end of this too. New line. And I close that off. Then I have to tell fprintf where I'm going to take these things from. Wherever I have this %40f, %04, %40f, I'm going to be taking numbers and putting them in there from an array. And I have to tell it which array to take it from. And so the array that I'm taking it from is the, what did we call it? I'm not even sure what we called it. Oh, it was the previous thing. Anyway, let's actually do the following candidates meet the age requirement instead of height requirement, because that's the one we're doing. We take it from age, first of all. So we go from age. So that would give us candidate 2. And then we would also take it from, take this thing from our applicants. We want to take it from applicants. And we want to take age from the first column, right? So we want to take age, comma 1. So, or sorry, age. Yeah, that's right. I think that's right. Let's hit enter and find out. Oops, I did something wrong here. Obviously. Oh. At this here, I need to put in, this needs to be put into square brackets so it knows that it's an array of numbers. So I put this into an array of numbers here. Let's see if that works. Oh, and it's fprintf, not fprint. I always do that. Fprintf. There we go. Let's see what happened here. Did something goofy, I don't know what. Oh, this is what I did wrong. In this this one I did this is not 4 space 0, it's 4.0. I don't know why I wrote it as 4 space 0. It's 4.0. That's better. Okay, so now, there we go. So now it prints it out. Candidate number 2 is 4 inches tall. Now, right here, you've got some things in here. You've got this 4.0 F here, you got this 4.0 F here. That's setting the amount of space in front of these numbers. So you can change that, you can change it to 2.0 or whatever else, whatever you want to do, but make it look nicer. So those are just some review things that we've done before and that you will need to be using here as we're starting to write more programs. And they give lots of examples of doing this kind of stuff. Lots and lots of examples. Let's take a look at this next one because it's slightly different. We're going to put things into, we're going to let's see, is that correct? I think it's correct. Trying to find where this thing starts here. Oh, here we go. Okay, so let's actually start on page 278 right now. Let's go ahead and clear everything out of here. Let's clear all of our variables and clear the screen. And in the next part, we're gonna do some temperatures, and we're going to extract some things from. We're gonna extract some numbers from an array of numbers, but we're going to put it into more than one thing, more than just a single column. We're going to have actual multiple things going on here. So we're going to start with temperatures. So we have temperatures. And temperatures in 3 different places in a clinic, it looks like. And we have, so in the first, every row represents every column represents a different station, I think is what they're saying. The column represents the number of the station where the temperature is taken. So 95.3 for the first temperature in the first column, 100 for the first temperature in the second column, and 98.6 in the third one. And then we go to the next row. Whoops. Next row, there we go. And the next row is going to be 97.4. And 99.2 and 98.9. The next row is going to be 100.1 and 99.3. And the last one is 97. So there is our temperature data. 3 columns. Each column is a different position and temperature is taken out of that position. Now, let's find where we have temperatures that are greater than 98.6 degrees. So we're going to use find inside of our thing temperature, where temperature is greater than 98.6. Right? That's what we're looking for. Find where the temperature is greater than 98.6. Now, just like normal, it's just going to return us this column of numbers that are the indices of, or the indexes of where this is. But remember that this thing has indexes, this has both rows and columns, not just a column or just a row. So how do we count this? The way that MATLAB counts is it starts in the upper left-hand corner and goes down. So this is the first one, this is the second one, this is the third one. The 100.1 is the third one. Then it goes to the top of the next column and goes down. Then it goes to the top of the next column and goes down. It's like reading a book with multiple columns of text, right? So, element 3, which one is element 3? What's the value of element 3 here? 100.1. What's the element of 4? What's the value of 4? 100.2, right? 5, of course, is 90.2. 6 is 99.3. And 8 is 1, 2, 3, 4, 5, 6, 7, 8, 98.9, right? And that's how MATLAB counts those. So you got to be aware of that, or you could get really confused. So those are the stations. That turns out that there are 5 stations. There are 5 measurements in those 3 different stations that are greater than 98.6. Now, how are we going to use this information to extract the temperatures out of your property? Well, what we would like to do is we would like to have this into rows and columns. And so what we're going to do is we're going to be a little bit clever. We're going to create an array of 2 numbers, an array of numbers called, there's going to be rows and columns. The first column is going to be called row. The second column is going to be called col, right? And this is going to be equal to, the numbers that we put in here are going to be equal to, we're essentially going to try to pull out which row and which column each of these numbers is in, right? And so find, again, temperature greater than 98.6. And look, it actually gives us now the row numbers and the column numbers. So the first one, which before was the third element, which is right here, is actually in the third row and the first column. Right? Third row, first column, that's where it is. So that's another way to extract that information. That one is possibly more useful because then you can take out individual things from rows and columns. So now let's go ahead with an fprintf. Let's do an fprintf thing. Fprintf. We're going to print out a statement that tells us about what the temperatures are in this, whatever it is. So, these are temperatures of patients in a hospital at different stations. So I guess we know now because I've never read it before. So it's fprintf, and then we put in the thing we want to actually print to the screen. Patient. So the patient's numbers are determined by the column number, right? So we want to take the column for each one of these things. So we're going to have to insert something here. So we're going to put a %3. Last time we did a %4 and it had that huge space. So we're going to do a %3 this time and hopefully have a little bit less space hanging out in here. We have to do a 0.0. If you remember back to the fprintf function, this is all just part of the syntax in putting together the fprint function. We're telling it what to put into that spot and how big a space to leave for it. At station. Oh, and we also have to include the F at the end of that. That tells us that we're going to put something in there. At station, and we're going to put something in here. What we're going to put in this one, though, is different. We're still going to leave the same amount of space for it and use the same font and everything and color. So we're going to use this thing right here. 3.0F had a temp. And I'm actually going to leave off this extra space here. We don't need an extra space there. And then we're going to do another, drop another number in here. There we go. We put in degrees or something like this, right? So now we've finished up that. Now we need to tell it where to take this information from. We're going to create an array of numbers. Oh, and we'll put in a new line after that too. Put in a / new line so that it puts the next one on the next line. We're going to do this. It doesn't like that, but we'll fix it in a second. Probably because I didn't finish with my. Yeah. Okay, so now we're going to make an array of 3 different numbers. The first number is going to be the row number. The second number is going to be the column number. So the first number being the row, that it tells you what station. The column tells you which patient, and the third one, no, the first one tells you which patient. The column tells you the row. The column tells you the station. And the third number is going to be their actual temperature. So that's going to be the actual number out of this, which is going to be, we're going to take that from the temperature thing, and we can just use the element that we put in earlier, right? We calculated the element earlier up here. We called it element, so we can just use element right there. Patient 3 at station 1 had a temperature of 2 degrees. That's not right. What did we do wrong? Something's goofy. Let's check this thing here. Row, column, yeah. So the row tells us which patient it was. The column tells us which station it was. And the temperature at element tells us what the temperature is. That should work. Oh, I know it went wrong. This last one, the temperature, we have to give more digits. So here we've told it to only give us a certain number of digits, but we have more digits than that. So we have to put in like, let's see what they do here. They do 6, and they do 1. So we're going to do 6. We're going to give at least 6 spaces there, and in those 6 spaces, we're going to allow ourselves one decimal place, and then we're going to hit enter. It's still not right. The numbers are in the wrong places. We did get our 0.2 and 0.9 here. Okay, so what it looks like we're getting is we're getting everything correct except this last one. 3, 1, 3, 2, no. Well, it has something to do with this order in which we've done this over here. And I don't know why it's not doing it right. It looks right in the code. Hmm. 3, 1, 2, 3, 2. 3, 1, 2, 3. Oh, I see what it's done. What it's done is it's put all these numbers in first, then all these numbers in second. So it's just done it turn by turn. It's done 3, 1, 2, 3, 2, and then 1, 2, 2, 2, 3, which is the second one, 1, 2, 2, 2, 3. And then it's just put in all, so it's done them all wonky. So I think what we want to do is, let me see here. Oh, I see what I did wrong. So I put them in columns. So essentially, we're just going down the columns here. What we want to do is we want to put them into rows. Into the I put the numbers across in this thing across this way. We wanted to put them down this way. So we wanted 3, 1, 2, this one, then this one, and this one going down in a column. And the reason that I didn't do that is because this needs to be inverted, needs to be flipped. And then we put it in and it will make it right. So there we go. That is the difference there. Okay, so a lot of that is review. A lot of that stuff that we're printfing and all this stuff is review, but we're adding into it this idea of finding things based on whether they're greater than or less than, and putting them into the code. We're going to take a little bit of a break now for maybe 6 or 7 minutes, and then we're going to cover the rest of the chapter, which is all about selection structures. And we have a couple of different selection structures that we use. particularly the if-then and the case statements. So let's take a little bit of break and we'll come back and do some selection structures. Ooh. All right, we're ready to go. So, on to selection structures. Selection structures are built-in capabilities of the computer to start making bigger decisions and start allowing the computer to wait until a certain condition appears and then to execute some commands. So in the case of selection structures, we're going to be comparing things, we're going to be using logic, we're going to be using the logic operators, and then after we use that logic operator, we're going to give the computer something to do when that logic operator has been satisfied, when it's positive or when it's negative or whatever else. And it starts like this. If. That's it. That's how you start it. And notice that it lights it up blue because MATLAB knows if means something to MATLAB. It starts something. And what it's going to do is it's going to wait now for you to make some kind of a comparison using the selection operators. At the end of it, you're going to have to end it. Very similar to a function. It needs to be ended because it needs to know when you've stopped giving it things to do after the comparison. So here's a very simple one. If that's not going to work unless we do something like this. Let's do it anyway. If G, and we're on page 283 now, if G is less than 50, we're going to hit enter, and notice that it hasn't executed anything because MATLAB is still waiting for you to put some things in here. So then we're going to display, in this case we want to display G is a small value equal to did something wrong there. Too many things over here. G is a small value equal to. So we're going to display this little phrase here, and then the next thing we're going to do is we're going to display actually G. Right? Great. I'm going to go ahead and put some suppressors in here, and then I'm going to end this statement. But the problem is it doesn't know what G is. MATLAB still doesn't know what G is, right? So this hasn't helped us much just typing it into the command window. Unless we knew what G was. If we said G, let's say that G is equal to 8, right? Oops. And then we write all this stuff again. Copy, paste, and then we hit enter. Then it will do what we told it to do. G is a small value equal to 8. Good enough, right? So this is a very simple use of this, but we will use this a lot in inside of a function. We build a function, and we want to choose between two things and to do something if it is one thing. This is what we would use to do it. Now, this also works if G is a large group of things, an array of things. So let's say that G is between 0 and 80 in steps of 10, right? So we go from 0 to 10 to 80. That's our G. It's a big array of numbers, whatever it is. We go ahead and we paste this little if G is less than 50, display G as a small value equal to G end thing. And it does, we do this here. Oops, what happened? Why didn't it work? Okay, let's try that again. Paste. If G is greater than 50, Oh, it's less than 50. G is less than 50. What did I just do? Oh, yeah, okay, I remember what I just did. So we ran this thing and it doesn't do anything. The reason it doesn't do anything is because this only works, this if end statement only works for arrays if it works in every part of the array. It has to work for every element of the array. So if G is not less than 50 for everything, then it won't do anything. Because we didn't tell it to do anything if G was greater than 50, and this thing has 3 elements of G that are greater than 50, 4 actually. It has 50, 60, 70, and 80, so it has 3 elements that are greater than 50. So, and one that's equal to 50. So it doesn't satisfy the conditions. If we changed our conditions to if G is less than 100, then it would go back to executing it. And it will tell us the entire value of G, right? But if it doesn't satisfy the condition, then it won't do anything because we didn't tell it to do anything if it didn't satisfy the condition. So how do we do something if it doesn't satisfy the condition? Well, we put in what we call an else statement, okay? So let's do the same one here. Let's paste in this. If G is less than 50, display this and display G. Else, let's add in a line here. Oops. Paste in here, and we'll add in a line. Crap. How do I do that? I have to erase this. So then I'm going to put in another line. I'm going to else. So the else tells you if this is not true, this is what I'm going to do next. I'm going to display G there we go, single quote. G is bigger than 50, or maybe it's just 50, right? And that's fine. So that's going to be my else, the else part of this. Oops, and I have to finish the statement. Copy this, put it back down here again. I have to finish my string here. Let's do it right there. And let's erase that one. And then let's end this. So I have to end it, right? And saying is G is bigger than 50 or it is 50, right? If G is less than 50 and so on and so forth. So, yeah. So, that's the if-else structure, as they call it. Let's do another one. This is a good example of where this is used. Let's say that x is equal to a bunch of numbers. Let's put in a bunch of numbers here, 7, 8, 2, 5, 6, -9, 3, 0, 21, 85, -5, whatever. Okay, so I got a bunch of numbers here. That's my x. Enter that in. Now I'm going to go ahead and put together an if-then statement, or an if-else statement. If x greater than 0. If x is greater than 0, then I want y to equal the log of x. All right? Else, I want to display this. The input for the log function must be positive, right? And then I'm going to end my structure, hit return. And apparently my x has some numbers that are 0 or negative. So the input for the log function must be positive. But I could also do something else. I could also, I mean, there's lots of things I could do with this structure. There's also a part called the else if. So I can have multiple, I can look at multiple comparisons. So here's an example. We're going to do ages here. Let's say I'm going to put in my age equals 43, because that's how old I am. So age equals 43. And then I say if age is less than 16, so I say I'll do display, you can't drive, right? You can't drive. Gotta put in your quotes, because that tells the computer that it's a string. And you can't put in an apostrophe as a quote because apostrophes are different here. Let's see, I'm going to search for apostrophe. Oops. Apostrophe. Okay, that's not helping. You can't drive. I'll just write it like that. That's fine. So you can't drive. I'll display that if you're less than 16. Now, and then if I want to do another one, let's say if I want to say if you're less than 18, else if is a new thing. So else if age less than 18. Said you, let's do, sorry, display. We can display you can drive, but you shouldn't. Right? And then else if age less than 65 will display you can probably drive, unless you are from Idaho. My mom's from Idaho, so I can make that joke. Right? And then we do another, then at the end, at the very end, so it goes through these things one at a time, one after the other. And at the very end, since we just have something left, we just have one thing left, else y, else we don't even have to do a, there's no, you don't have to do a comparison in this one. We just do else if we get to anybody that's greater than 65 or older, we just display you can't drive again, right? And we're done. So we end it. And so apparently, since my age is 43, well, I can probably drive unless I'm from Idaho, which I'm not. So it's good to go. I'm good to go, right? So this can do a lot of things. You can make a lot of choices using the if, the else, and the else if statements within the if structure. It's good stuff. They also show you a very nice flowchart for this. So you can see how flowcharts are done for if, and else if. There's always a true that takes you out of decisions and so on and so forth. Good resource for when you're doing your worksheet. All right. Let's see, moving on. Now to the next one. This one's called the switch and case. Switch case structure is what it's called, or sometimes just the case structure. But this one is a very interesting one and also extremely useful. And essentially what you're going to do is you're going to have this option of switching something, of replacing something, but only in a certain case, only if a certain thing is fulfilled. So, and then you have code. Then you can have code that can be let's see, is that right? Did I say that right? I'm trying to remember. Yeah. So anyway, yeah. So you have this set of things that you can put into something. Those are the things you can switch in or replace in, I guess, is a way to think of it. But then you only do then you execute certain things if you get that particular thing put in. So, and it's much easier to see by doing, again, just like everything else. So let's actually do an example. So let's say that we are going to talk about cities. So city. City is going to equal, in input from the user, where we're going to say, we're going to ask the user to enter their city. Enter the name of your birth city. Right? And we close that code out. And we're going to insert that into a string variable. So we have to tell MATLAB that we're using a string variable, putting the quotes, S quote, at the end of this, right? So the name of your birth city is going to go into this thing called city, this variable called city, and it's going to be a string variable. And then we're going to start this switch thing, okay? So enter the name of your birth city. My birth city is going to be San Jose, and it's going to save that. So there's my city, San Jose. Now we're going to make this thing called switch, and again it's going to highlight it in blue. Oops. Let's try that again. Switch. And the variable that we're going to use with this switch is going to be city. So the thing that's going to go into this is city. That's the thing that you're switching in, that you're putting into this thing. And it's kind of, you could also think of it as switching this thing on. But then you're going to tell it the different cases. For the case, now our variable is a string, so each of our cases have to be a string, so we have to use quotes. So my first case is going to be North Platte. Right? North Platte is going to be the first case. What's going to happen if I was born in North Platte? Well, I'm going to tell it to display something, or I'm going to tell it to calculate something, or I'm going to tell it to do something that's related to North Platte. What do we want this thing to do with birth cities? Well, let's imagine let's guess who their favorite football team is, right? So let's display, or their favorite sports team or something. You are let's try this again. You are a Cornhusker, right? You're a Cornhusker. You're going to display that. So if they're born in North Platte and they type in North Platte, you just display you are a Cornhusker and you're good to go. That's the first case statement. The second case statement can be for, let's do Denver, for example, right? You say, display, I'm sorry that you like the Rockies, or something like that, right? So that's your second case. Your third case might be San Jose then, right? San Jose. And maybe you display that first year for the Sharks was good. None of them since, but the first one was good, right? Whatever. And of course, at the end, you're going to put an and statement on, but you can also put in an else, but it's not in a case statement, it's not called an else, it's called an otherwise. So otherwise, in this case, I'm probably going to want to display something like, where is that? Because I don't have that city in my list, right? And then I do need to end it, and I'm good to go. So the first year for the Sharks was good, is the one for San Jose, and that's what comes out. So that is the switch case statement. It's pretty straightforward, not terribly difficult. But again, in the book on page 292, they show you how to make a switch case diagram when you're doing your flow diagrams, your flow charts. Now we're going to do a little bit of GUI. You guys know what GUI means? Graphical user interface, right? Excuse me. MATLAB actually has a fair amount of graphical user interface stuff built into it. We're going to use the menu. So, menu looks like this. Menu. Select, oops. Select city, right here. And close that, and then you have a comma. There we go. So select city, and then you put a comma, and then you put in your first option, and then a comma, and then your second option. But these options need to be named in quotes. So we'll put in Boston. We'll put in whatever cities, Boston, then comma, then Denver, then close quote, then comma, then San Jose, like that. And that gives us this. It gives us a little menu box to select from, a little push button box. Kind of nice. Then I can choose San Jose, for example. Right? Normally what it does is normally what MATLAB will do is it'll just tell you which answer you chose. You chose the third answer in the menu box. However, we can use this to put input in to a little program. For example, to put input into this this program that we wrote up here, switch city, thing, this switch case thing. So let's actually open up a little. Let's open up a little thing up here. Let's put this in up here. Oops. We're going to copy this switch statement that we made here, put that in up here. And before the switch statement, we're going to put in this menu thing here. So how are we going to do this? We're going to do this as an input. Input is going to equal now from the menu, and we'll use this same thing that we did down here. Similar anyway. Copy. Paste. Select city, Boston, Denver, San Jose, but we'll use North Platte. Right. And now let's put that into input, but we're using city, so we might as well call it city instead of input, right? We'll call it city. City equals from the menu right there, we're good to go. Let's go ahead and run this thing, see how it works. Save it as untitled, sure, whatever. Replace it. And we run it. It says select city, Denver, North Platte, San Jose. I'll choose North, oops, I chose North Lat. And it says, where is that, right? Because it doesn't know, because I wrote it wrong. I wrote it as North Platte. So I need to do that. Case North Platte, let's see here. Let's go back to our thing up here. It's not North Lat, it's North Platte. Okay, let's run that again. Choose North Platte. And it still says, where is that? Why is that? Can you tell why that is? Can you see where my mistake is? What's that? Well, what we did is we said that the city is equal to 1. The first thing on the menu, right? It doesn't know that the first thing on the menu is called North Platte. So we actually have to name it North Platte after we know that they've chosen the first one. And that can be a little bit, so that can change how we do things. So instead of case North Platte up here, we'll call it case 1. Instead of Denver, we'll call it case 2. Because that will be, and we don't need quotes anymore because it's just going to be numbered. Instead of San Jose, we can just put in case 3. And we're good to go. So now we can run this, and we can choose North Platte, and you're a Cornhusker, right? We can run it again. We can choose Denver. I'm sorry you like the Rockies. Run it again, San Jose. First year the Sharks were good, right? But you have to make sure that the output from the things that you're using are the output that you think you're going to get. In this case, the output from menu gives you the thing that you chose as a number. The first thing, the second thing, the third thing, or so on and so forth. And so that number needs to be translated into the name of a city somehow. You can do it like I did it, just changing it from 1 to 2 to 3. Or you could change it by assigning 1 the name North Platte. You could do it that way if you want as well. Either way. And they also give you an example of how to do that with your flowchart. So, switch case, menu, if, else, we're done. That's this chapter. So, your job is to go in and get the homework done for week number 8. Which will include else if statements and logic statements and, if else statements, logic statements, and switch case statements, and learn how to use those. In some cases, I'm just going to have you write the code. In some cases, I'm going to actually ask you to write a function. So you have to go back and remember how to write a function, and then write that code inside of that function, so that it runs like a function. Any questions about what we're doing this week? Okay. This is starting to look like real programming, hopefully. And it's going to be even more so next time, and after that even more so. It's only a couple weeks now until you'll be writing full graphical user interface programs where you're getting lots and lots of interaction with the computer and the user that is much more like you're used to. And then you'll be ready to make a game for the final project. Hopefully we'll have time for that. I think we will. So, have a good week, and we'll see you next time. Don't forget all the parts of the homework, including the notes and the document, the shared document, and also this week we have the worksheet. So it's a little bit different this week. Don't forget that.